Hello everyone, I'm Tin, founder and CEO of Open Motors, a company backed by Y Combinator and based in Silicon Valley in China. Today I'm going to talk about battery swap and energy storage for the grid. So the rise of EV is a massive trend that over the internal combustion engine vehicles. And you see companies like Tesla, they are doing an amazing job integrating seamlessly energy and mobility solutions. And according to Bloomberg, we might see the sales of electric vehicles surpassing the ICE, internal combustion engine ones, in 2040. Another big trend that is happening is that the lithium-ion battery prices keep falling down. Okay, and you see that in about 10 years of span, the delta is about 90%, pretty massive. Obviously, there are differences and problems. So the energy density is definitely one of them. And in a 1 kilogram of gasoline, you actually have 10 kilowatt hours of energy, while in a 1 kilogram of a lithium-ion battery, you only have 0.14. And fast charging is another huge challenge because we can see it easily in our smartphones or laptops. Okay, the more we use fast charging, the more our battery degrade very quickly, and this is happening also with EVs. Okay, so yeah, fast charging is literally killing the chemistry inside the battery. Another big trend is related to the rise of the services such as Uber, Didi, Ola, Grab, Amazon, food delivery. Okay. And over the private car market that is declining pretty fast. In fact, according to Bloomberg, we might remember 2019 as the peak of production and peak of sales of especially in the private car market. Okay, so big groups such as Geely from China, this group owns Volvo, 50% of Smart, 10% of Daimler, or Tata from India that owns Jaguar and Land Rover. They are facing massive double-digit losses in their sales and profits. And even China, the #1 market, cannot save the whole industry forever. Actually, things there are changing pretty fast. And the new opportunity is mobility as a service, also known as MaaS, combined with AI is going to be a huge opportunity of over $7 trillion by 2050, according to Strategy Analytics and Intel. And in China, the biggest local car manufacturer, together with Nielsen, they said that mobility as a service most likely will become dominant, bigger than public transportation and personal mobility combined. Thankfully, all these insights, all this data, actually, thankfully we have the opportunity to get in touch with some of the biggest service companies around the globe, moving people, moving goods, also global Fortune 500 companies in energy and infrastructure. So I'm going to share you more data, okay, such as the daily usage, for example. The private car markets is actually pretty different from services, fleet operators. So the average usage of a private user globally is about 2 hours of driving daily, and the lifespan of the vehicle is about 10 years. Which means that the vehicle is basically parked easily more than 90% of the lifetime. Then, on the other hand, we have fleet operators with their services that are constantly moving people and goods up to 24 hours a day, non-stop. So obviously the usage is at least 10 times more, and the lifespan drops dramatically, sometimes less than 2 years. So we have big problems, such as the warranty. The standard warranty of 100,000 miles or kilometers, about 8 years, is more than okay for private users. But for service providers, this is definitely not enough. These cars are actually used many hours, and easily in a year they reach 100,000 miles or kilometers pretty fast. Okay, so I give you an example. Grab, just in 2018, they almost reached 1 billion of kilometers driven by their fleet. And fleet operators, they care mostly about one thing called TCO, total cost of ownership, which means the initial cost of buying a vehicle, maintenance, repair, insurance, taxes, everything that you can see here. And there's an interesting study from McKinsey about how to make the electric vehicle industry profitable, because right now most of them are losing money per vehicle sold. And in this report, actually, they say that economically it makes sense to target fleet customers, especially in the high mileage category, and they prioritize TCO higher than any other buying factors. So technologies such as a battery swap can help to optimize and lower the cost of the TCO. Even Tesla, they tried to put this in the market some years ago, but it didn't went pretty well. And this is actually not a new technology. Is the first battery swap technology service actually started in 1910. And recently companies like these 3 companies, they tried to put it in the market in the recent years, but it didn't went very well. Okay. And one of the main reasons is that for these 3 players, one station cost, excluding batteries, is above $1 million US. Very expensive. So that's a pretty bad news for all the fleet operators, because most of the car companies are focusing on the private car market, and in the transition from ICE to electric, from combustion to electric. And there is no major advancement in advanced modularity, okay? Like in airplanes from Boeing or Airbus. The TCO is very, very low. Actually not very, very optimized. Also the hardware upgradability of fleets, actually this is not very happening. Maybe just a few parts can be upgraded. If you want to have new features on your fleet, you basically need to replace the entire fleet. And the battery, so actually before that, actual cars, including EVs, they're like iPhones with 4 wheels. You can probably do software updates over the air, everything, but you cannot replace hardware easily. And battery swap, unfortunately, is not available or is very expensive. The good news is, thankfully, we are doing it. So we are really pushing the TCO optimization for fleet operators, and we came up with a solution of a vehicle and a battery swap technology. The vehicle is called EDIT, and the key technology is advanced modularity. And here's the video.
Introducing the future of the automotive industry. A ready-to-use, road-legal vehicle designed and engineered in Europe. Featuring a platform that is entirely modular, allowing vehicles to adapt to any situation, any location, any need. A truly adaptable vehicle, designed and engineered for services. The modular platform allows for truly future-proofed vehicles, ready to easily repair, refurbish, and upgrade any part necessary, with flexibility to choose even up to Level 5 complete autonomous driving. A fleet of self-driving, truly white-label vehicles can operate up to 24 hours every day, allowing for maximum efficiency. And because the entire platform is built on a modular architecture, fleets of vehicles can last 10 times longer, customizable, modular, and upgradable, designed to last, designed to evolve.
So we extended the advanced modularity of the vehicle to the battery. Now you can detach the battery and swap it in just 2.5 minutes. Very, very fast. And two main things related to this. First is the battery swap is available to all vehicle manufacturers, cars, mini trucks, and buses. And we already talked with some of the biggest one. And second is that the batteries inside these stations can be used as energy storage. And third is that, let's say, our technology, we can say that it's comparable, actually it's more advanced, but the only thing that is not comparable is the cost. We are several times more affordable than actual competitors. So we studied a lot existing solutions, and we found out that most of the actual battery swap are basically over-engineered, okay? For the alignment system, locking and unlocking, some solutions are definitely not optimal. So we took our experience coming from Formula One and aerospace to make something leaner, faster, and way more efficient in terms of cost. And actually we achieved remarkable results, both in the vehicle, both in the infrastructure swapping. So the TCO of Edit is 2 times lower any actual cars in the market. As well, the energy cost, we can leverage the lowest peak. The moment you detach, we have the freedom to charge it at the cheapest moment. Then the battery degradation. So fast charging is destroying the chemistry inside the battery because of the heat and everything. But we can detach this battery and we can charge it at the right temperature and the right speed. So we can extend the lifespan of the battery, which is the most expensive component in the EV, up to 3 times more. And the cost of the station, for the reason I explained, is actually on average 10 times lower. The cost of deployment of the overall infrastructure also is very, very less expensive. Okay, imagine just the impact of the space. In a normal charging station, in this space, you park your EV to charge 7 to 10 hours a day. So in this space, you can only charge 2 to 3 vehicles max in one day. With our technology, in the same space, 2.5 minutes and then you go. 2.5 minutes and then you go. So we can serve several hundreds of vehicles in a very compact space. This is a huge problem, the space that cities like London or Los Angeles definitely have. And obviously then the timing, okay, so 60 minutes of fast charging compared to 2.5 minutes of swapping a battery. So basically is a difference. We are 20 times faster, even faster in gas stations. So here's a comparison between actual solutions. You can see clearly that even with the cheapest player, we are several times more affordable. And in this example, which is Bangkok, you see that with a 5 million investment, you can, with the best in the class, only have 13 stations. Instead, with the same investment, we can cover the entire city with 100 stations. So these stations, so inside the battery swap station, inside you have all the batteries, okay? And we can leverage these batteries to do energy storage. Just like Tesla did, actually they did an amazing job in South Australia with a gigantic, actually the biggest lithium-ion battery in the world, with a capacity of 129 megawatt hour. They proved that the technology is working, they are stabilizing the grid, and the ROI, the return on investment, is very, very good. And that's why they decided to expand this battery 50% more. So there are companies working in energy storage, such as Enel, the biggest energy company in Italy and South America, working with Nissan, okay, in a technology called V2G, vehicle to grid, leveraging existing batteries to stabilize the grid. So when the vehicle is connected, charging, you can leverage this to harvest the energy or give back the energy. And that makes a lot of sense, but for services, fleet operators, this is definitely not that good. Instead, we are working on let's say the next step of this technology, and we call it battery to grid. Instead of leveraging the battery inside the vehicle, because if you're driving, you're not connected to the grid, so you cannot do V2G. And when you are connected to the grid, you cannot drive, right? So instead, we leverage the battery inside the batteries, the stations, okay, and to stabilize the grid. So the battery is the central piece of the puzzle. We can harvest energy, we can charge all these batteries, and at the lowest peak when it's cheaper, so we can provide very affordable energy to mobility service providers, okay, such as Uber, Didi, Amazon, okay. So we're solving the mobility problem, and the spare capacity acts as a buffer to stabilize the grid. We can harvest the extra energy produced by solar or wind farms. This is one of the biggest problems with renewable sources. And we can give back this energy to the grid when it's needed. If you're interested to know more, you can add me on LinkedIn. That's my full name, Tin Han Liu, and or you can shoot me an email. Thank you.